Take a breath. Hold it for a moment. Now let it go. What did you just release into the world? You call it breath, a mist of warmth and water vapor. But it is something more. It is a ghost. It is a story. It is a traveler that has journeyed for 4.5 billion years to have this brief, fleeting encounter with your lungs. In that single exhalation, there are atoms of carbon that have seen epochs rise and fall. An atom that was once locked in the limestone heart of a mountain, feeling the slow, grinding pressure of a continent. An atom that was part of the cellulose spine of a fern in a carboniferous swamp, drinking in a thicker, hazier sunlight. An atom that was part of the shell of a microscopic creature drifting in a primordial ocean. And before that, an atom that was forged in the stellar crucible of a long-dead star. You have just released a history of the world. And in the same moment, you have breathed in another. A different story, a different traveler. This is the journey we are here to trace. Not a journey of miles or years, but a journey of being. A journey through air and ocean, through forest and stone, through life and death and life again. It is the story of an element, the fourth most abundant in the universe, the architect of all known life. It is the story of carbon. We are told a simple story in school, a neat diagram of circles and arrows. The tree breathes in carbon dioxide. The animal eats the tree. The animal breathes out carbon dioxide. The tree dies and decomposes, returning its carbon to the soil. A perfect, closed loop. A balanced system. This story is true, but it is a children's story. It is a sketch of a single room in a mansion of incomprehensible size and complexity. The reality is far stranger, far older, and far more mysterious. The truth is, the world you perceive is an illusion, a beautiful and convincing lie your senses tell you to help you survive. You see a forest as a collection of separate, solid things. A tree, a deer, the soil, the air between them. Your mind carves the world into nouns, into objects, because it is useful. But nature does not speak in nouns. Nature speaks in verbs. It speaks in processes, in flows, in cycles. That tree is not a thing. It is a slow-motion fountain, drawing water and nutrient from the earth and pulling carbon from the air, weaving them together with sunlight into a temporary form you call wood. That deer is not a thing. It is a wandering, metabolizing vessel, borrowing atoms from the plants it eats and the air it breathes, assembling them into a shape you recognize, only to release them again with every breath, every movement, every beat of its heart. And you are not a thing. You're not a static object. You are a pattern. You are a standing wave in a river of matter and energy that flows through you. The carbon that makes up your muscles, your skin, your bones, the very neurons firing in your brain as you process these words, is not your carbon. It is on loan. You are its current custodian. In 7 years, nearly every atom in your body will have been replaced. You are a river whose water is always changing, yet somehow the river remains. This is the first deconstruction. The lie is solidity. The lie is permanence. The lie is separateness. The truth is connection. The truth is flow. The truth is a grand, planetary system of exchange, a balancing act so vast and intricate that it borders on the miraculous. This is the carbon cycle, not a simple loop, but a global metabolism, the breathing of a planet. And understanding it changes not just how you see the world. It changes how you see yourself. To truly understand this journey, we must go back. We must travel in time, to an age when the world was a puzzle and the fundamental forces of nature were still cloaked in mystique and superstition. The very air we breathe was a mystery. The year is 1771. The world is lit by candle and fire. The great engine of industry is just beginning to stir, a sleeping giant. The nature of matter itself is a subject of fierce debate, caught between the fading whispers of alchemy and the nascent dawn of chemistry. Enter a man named Antoine Lavoisier. A Frenchman, a meticulous accountant by trade, he brought the rigor of a ledger book to the chaos of the laboratory. He was not a poet. He was a decoder. He believed that nature, for all its seeming magic, operated on a strict budget. Nothing was created. Nothing was destroyed. It only changed its form. For centuries, people had known that if you burn a piece of wood in a sealed container, it eventually extinguishes. They called the resulting air fixed air, an air that could no longer support fire or life. They knew that animals, too, placed in a sealed container, would eventually perish, leaving behind the same useless air. But why? What was this invisible transaction? Lavoisier, with his scales and sealed glass jars, began to track the accounts. He measured everything: the weight of the wood before burning, the weight of the ash after, the weight of the air itself. In a series of breathtakingly precise experiments, he demonstrated the truth. Fire was not an element that was released from wood. Fire was a process, a rapid combination. The wood was joining with a part of the air, a substance he would eventually name oxygen. And in the process, it was releasing another substance, that fixed air, which he showed was a combination of carbon and oxygen, carbon dioxide. But his genius did not stop there. He placed a guinea pig in a specially designed chamber, an ice calorimeter, and measured the heat it produced by how much ice it melted. He measured the carbon dioxide it exhaled. He then burned a piece of carbon in a similar apparatus and compared the numbers. The conclusion was revolutionary. It was unsettling. It was profound. The breathing of an animal and the burning of a candle were chemically the same thing. Life was a slow fire, a gentle, controlled, biological combustion. With that single insight, the walls between the living and the non-living began to dissolve. The animal was not a magical, vitalized entity separate from the world. It was a chemical system, participating in the same fundamental processes as a simple flame. The carbon in the food it ate was its fuel. The carbon dioxide it exhaled was its smoke. Lavoisier had drawn the first arrow in the great diagram of the cycle. He had decoded a fundamental secret. The idea lay there, a seed of understanding. For the next century, science built upon it, discovering the role of plants, realizing they performed the reverse process. Photosynthesis. They were not just passive scenery. They were the planet's other lung. They inhaled what the animals exhaled. They were slow, green engines, using sunlight to break apart the bond of carbon dioxide, using the carbon to build their own bodies and releasing the oxygen as a gift to the sky. The cycle seemed simple. It seemed balanced. But another mind, a different kind of thinker, was looking at the bigger picture. Not just a single animal or a single tree, but the entire planet as a single system. His name was Svanne Arrhenius, a Swedish scientist, a visionary, a man you might call prophet. In the late 1800s, he was wrestling with a different question. What controls the temperature of the Earth? Why was the planet not a frozen ball of ice, like its neighbors in space? He knew about greenhouse gases. He knew that certain molecules in the atmosphere, like water vapor and carbon dioxide, were transparent to the incoming light of the sun, but opaque to the outgoing heat radiating from the Earth. They acted like a blanket, trapping warmth. Arrhenius began to wonder. The industrial age was now in full swing. Humans were digging up ancient, buried carbon, coal, and burning it on a massive scale. They were, in effect, accelerating a geological process, releasing the carbon of 100 million years in the span of a few generations. They were adding to the planet's atmospheric blanket. So he sat down to calculate. For months, by hand, he performed tedious, repetitive computations. He tried to estimate the effect of doubling the amount of carbon dioxide in the atmosphere. His calculations, published in 1896, suggested it would raise the planet's temperature by several degrees. He was not alarmed. He came from cold country. He thought a warmer world might be a better world, allowing crops to grow further north. He imagined future humans consciously managing the planet's thermostat by burning coal. He saw the effect, but he could not see the consequences. He was a prophet who spoke a truth he himself did not fully comprehend. The initial paradox was born. Humanity, a biological component of the cycle, was suddenly becoming a geological force. A species that was born of the planet's balance was now consciously, deliberately tipping the scales. But the scales were so vast, so immense, who could possibly measure it? Who could detect the breadth of a civilization on the scale of a planet? For half a century, the idea remained a curiosity, a theoretical possibility. The Earth was too big, the oceans too deep, the atmosphere too vast. Surely, nature would absorb our emissions without a trace. The system would balance itself. It always had. This was the prevailing belief, an article of faith, until a man went up a mountain to listen. His name was Charles David Keeling. He was not a decoder like Lavoisier, nor a prophet like Arrhenius. He was a watcher, patient, meticulous, relentless. In 1958, Keeling decided to do something that had never been done before. He wanted to measure the concentration of carbon dioxide in the atmosphere, not just once, but continuously, day after day, year after year, with extreme precision. He sought a location far from the complicating breath of cities and forests, a place where he could measure the clean, well-mixed background air of the planet. He chose the volcano of Mauna Loa on the Big Island of Hawaii, a remote peak surrounded by thousands of miles of ocean, its summit piercing the lower layers of the atmosphere to touch the global winds. There, he set up his instruments, and he began to watch. What he found was astonishing. The first thing he noticed was a rhythm, a pulse. Every year, the concentration of carbon dioxide in the planet's atmosphere would fall during the northern hemisphere's spring and summer and rise again through the fall and winter. He was seeing the planet breathe. When the great forests of North America, Europe, and Asia awoke in the spring, they drew down a colossal amount of carbon from the air, a planetary scale inhalation. And when they went dormant in the fall, respiration from soils and ecosystems dominated, and the levels rose again. A planetary exhalation. It was the first time the metabolism of the entire biosphere had been seen in a single, continuous measurement. It was a vital sign for planet Earth. But as the years turned into a decade, and the decade into two, another, more disturbing pattern emerged from the data. Superimposed on that annual, rhythmic breath was a steady, relentless, upward climb. Every year, the peak of the cycle was higher than the year before. Every year, the trough was higher too. The planet was not fully exhaling what it had inhaled from our emissions. Roughly half of the carbon dioxide humanity was pumping into the air was staying there. The planet was slowly, steadily accumulating a carbon fever. The Keeling curve, as it came to be known, was the planet's diary. It was the unambiguous fingerprint of a civilization on the chemical composition of the sky. The vague prophecy of Arrhenius was now an observed fact. The balance was broken. This is the moment the children's story ends. This is the moment we are forced to look into the vast, intricate, and now disrupted machinery of the carbon cycle. We must leave the quiet laboratory and the lonely mountaintop and dive into the great reservoirs of carbon themselves to understand the rules of this unseen world. Let us begin with the air. The atmosphere. You see it as empty space, as a transparent void. But it is a river, a vast, gaseous ocean that envelopes the world in constant motion. And in this river flows the carbon, mostly in the form of carbon dioxide. Think of a single molecule of CO2, a central carbon atom flanked by two oxygen atoms. It is simple. It is elegant. It is incredibly stable. It vibrates and spins, absorbing and re-radiating infrared heat, a tiny, invisible gatekeeper of the planet's warmth. There are roughly 420 of these molecules for every million molecules of air. It sounds like so little. A trace amount. How could something so scarce be so powerful? This is one of the first mysteries. It's like a single drop of potent ink in a vast tub of water. The power is not in the quantity, but in the quality. The specific physical properties of that molecule allow it to interact with energy in a way the other 999,999 molecules do not. It punches far, far above its weight. For at least 800,000 years, we know from the stories told by ancient ice cores, the concentration of this molecule in the river of air stayed within a narrow, stable band. It fluctuated between about 180 parts per million during the deep freezes of the ice ages and about 280 parts per million during the warm interglacial periods, like the one that allowed human civilization to flourish. For hundreds of thousands of years, the planet's breathing kept it within this safe channel. The exchange with the oceans and the land was in a dynamic but stable equilibrium. Now, we are at 420 parts per million and rising. We have pushed the concentration to a level unseen in at least 3 million years, and possibly far longer. We have done this in the geological blink of an eye. We have thickened the river. We have changed the very quality of the sky. Where does it go? The air is only the most immediate, the most obvious place for the carbon to be. It is the transit lounge, the great crossroads. From here, the carbon atom can embark on one of two great journeys: down into the water or down into the land. Let us follow it downwards into the blue immensity of the ocean. The ocean is the planet's great memory. It is deep, it is dark, and it is slow. It holds 50 times more carbon than the atmosphere, and 20 times more than all the plants and soils on land combined. It is the true titan of the carbon cycle. When a molecule of carbon dioxide from the atmosphere meets the surface of the ocean, it does not simply float there. A chemical conversation begins. The CO2 dissolves into the water. It is a physical process more efficient in cold, turbulent waters like the North Atlantic or the Southern Ocean. But then something else happens. A transformation. The carbon dioxide molecule reacts with a water molecule. It becomes H2CO3, carbonic acid. This is a critical moment. The carbon is no longer a gas just visiting the water. It has become a part of the water's fundamental chemistry. And carbonic acid, as its name suggests, is an acid. It wants to release its hydrogen ions. In doing so, it makes the water more acidic. This is the shadow side of the ocean's great service. For every ton of carbon dioxide it absorbs from the atmosphere, calming the skies, it pays a price in its own lifeblood. The oceans have absorbed about a third of all the carbon humanity has emitted, and in doing so, their surface waters have become about 30% more acidic. This is not a metaphor. It is a chemical reality, a change with profound consequences for the life that has evolved to live within a stable, predictable chemistry. But the journey is not over. The carbon, now in its new acidic form, can continue its descent. Some of it is taken up by the smallest of living things. Phytoplankton, microscopic green drifters that are the foundation of the entire marine food web. They're the grasses of the sea. Like plants on land, they photosynthesize. They take that dissolved carbon and, using the sunlight that penetrates the upper ocean, they build it into their own tiny bodies. They become little packets of solid, organic carbon. Some of this carbon is eaten, passed up the food chain from tiny zooplankton to fish to whales. It becomes part of the fast, living cycle of the sea. The whale breathes, releasing carbon dioxide back into the water. The fish dies, and its body is decomposed by bacteria, releasing its carbon again into the surrounding ocean. But some of it, a small but crucial fraction, sinks. This is the biological carbon pump, a slow, gentle, unceasing snowfall of organic matter into the deep ocean. The dead phytoplankton, the fecal pellets of tiny creatures, the carcasses of larger animals. A constant drizzle of carbon, falling from the sunlit world of life into the cold, dark, crushing pressure of the abyss. Down it goes, through the twilight zone, where strange, ghostly creatures consume what they can. Down further, into the abyssal plains, thousands of meters deep, a world of perpetual night. Most of this falling carbon is consumed and respired by bacteria on its long journey down. But a tiny fraction, less than 1%, makes it all the way to the seafloor. There, it becomes part of the sediment. It is buried. It has been removed from the active cycle. It has entered the slow storage of the earth. A journey that began in a smokestack might end here, in the silent mud of the ocean floor, where it can remain for thousands, even millions of years. There's another path down, a chemical one. Some of that carbonic acid reacts with other ions in the seawater to form bicarbonate and carbonate ions. These are the building blocks for shells and skeletons. Think of a clam, a coral, a microscopic coccolithophore, plating itself in tiny shields of calcium carbonate. They are not making these shells from nothing. They are pulling the transformed carbon out of the water, combining it with calcium, and building their homes. They are biological masons, turning a dissolved gas into solid stone. When these organisms die, their shells, too, sink. This is another form of carbon snow. Not organic, but mineral, a rain of future limestone. It settles on the seafloor, building up over millennia, layer by layer. The white cliffs of Dover are nothing more than the compacted bodies of trillions of these tiny, carbonate-shelled organisms from a long-ago sea. They are a monument to the power of the ocean to sequester carbon, to take it from the fast cycle of air and life, and lock it away in the deep, slow cycle of geology. This entire system, the dissolution at the surface, the biological pump of sinking life, the chemical pump of sinking shells, is how the ocean breathes in. But the ocean also breathes out. It is not a one-way street. In some parts of the world, especially in the warm tropics, the ocean releases carbon dioxide back into the atmosphere. And the great ocean currents, a global conveyor belt, act like a slow digestive system. Water that sinks in the North Atlantic, rich in carbon, may travel for 1,000 years in the deep ocean before it resurfaces in the Pacific or Indian Ocean, older and ready to release some of its ancient, stored carbon back to the sky. So the ocean is not a simple sponge. It is a living, breathing, chemically complex entity. It is a buffer. It is a memory bank. It is both a savior and a victim in this story. It has slowed the warming of the planet, but at the cost of its own internal health. It has hidden our carbon away in its depths, but that deep water will one day return to the surface. The ocean has given us time, but the ocean has a memory, and it does not forget. The carbon we put there is not gone. It is simply on a longer, slower part of its journey. Now, let us return to the surface and follow the carbon atom that chose a different path. The path not into the water, but onto the land. The land is the realm of fast carbon. It is a world of vibrant, chaotic, and rapid exchange. If the ocean cycle is a slow, deep breath measured in centuries, the land cycle is a staccato of quick breaths measured in seasons, years, and decades. Here, the primary engine is life itself, in its most visible form, photosynthesis. Imagine you are standing in a forest, a temperate forest, an Amazonian jungle, a boreal wood. Look around you. Everything you see that is alive, the towering trunks of the trees, the ferns on the ground, the moss on the rocks, the insects, the birds, the mammals, is made of carbon that was very recently floating freely in the atmosphere. A tree is solidified air. Let that sink in. It is not an exaggeration. A tree is built of carbon dioxide, woven together with water by the energy of the sun. The vast majority of its mass, its solid substance, comes not from the soil, but from the thin, invisible air. It is a miracle of alchemy that happens silently, all around us, all the time. A single, large tree can inhale dozens of pounds of carbon dioxide in a single day, transforming it into wood, leaves, and roots. An entire forest is a colossal lung, breathing in the sky. Globally, the land plants pull about 120 billion tons of carbon out of the atmosphere every year, an amount equivalent to all the carbon in the entire atmosphere. It is a staggering transaction. The planet's land-based life inhales the entire sky's worth of carbon every 8 years or so. But of course it breathes out as well. Every living thing respires. The tree itself, at night, when the sun is gone, burns some of its stored sugars for energy, releasing carbon dioxide. And all the animals, from the smallest microbe to the largest elephant, are part of this exhalation. They eat the plants or eat other animals that ate the plants, and through their metabolism, they return that carbon to the atmosphere with every breath. And then there is death. When a tree falls, when an animal dies, its journey is not over. Its body, this carefully assembled library of organic carbon, becomes a feast for the unseen world. The world of decomposers. Fungi, bacteria, insects, worms. They are the planet's recyclers. They break down the complex organic matter, taking the energy they need, and in the process, they release the carbon back into the atmosphere as carbon dioxide through their own respiration. This is the fast part of the land cycle. Inhalation through photosynthesis, exhalation through respiration and decomposition. For millennia, these two processes were in near-perfect balance. The amount of carbon breathed in by the plants each year was almost exactly equal to the amount breathed out by the entire ecosystem. Almost. A small amount of carbon does not get immediately recycled. It enters the soil. It becomes part of the rich, dark, complex substance we call humus. These are tough, resilient organic molecules, the remnants of decomposed life that can persist in the soil for decades, centuries, or even millennia. The world's soils are another great carbon reservoir, larger even than the atmosphere and all the plant life combined. It is a hidden, subterranean storehouse, a slow, lingering memory of all the life that has lived and died on that patch of ground. Tilling the soil, exposing it to the air, is like opening the doors to this ancient bank and letting the carbon rush out. And sometimes, under very specific conditions, the carbon goes even deeper. Imagine a vast swamp 300 million years ago. The air is thick, warm, and rich with oxygen and carbon dioxide. The plants, giant ferns, and club mosses grow to enormous sizes. When they die, they fall into the stagnant, oxygen-poor water of the swamp. The normal process of decomposition cannot happen here. The bacteria and fungi that would normally break them down cannot survive. So the dead plants just pile up, layer upon layer upon layer. They are buried. The pressure of their own weight, and later the weight of sediments washing over them, begins to work on them. Over millions of years, the heat and pressure cooks this buried plant matter. It drives off the water, the oxygen, the nitrogen. It concentrates the carbon. That swamp of ancient life becomes a seam of coal. A similar process, with marine plankton sinking in anoxic seas, creates oil and natural gas. This is the great exception to the land's fast cycle. This is carbon being taken out of the system and put into geological storage. Is the Earth performing a deep burial? For 300 million years, this carbon was locked away, taken out of the conversation between the air, land, and sea. It was a one-way trip to the lithosphere, the Earth's crust, until we came along. Until we invented the shovel, the drill, and the engine. We became a species of industrial necromancers, raising the ghosts of the Carboniferous period. We found this buried treasure of concentrated energy, and we set it on fire. In the space of just 200 years, we have exhumed and burned a significant fraction of all the life that was buried over hundreds of millions of years. We are reversing a geological process with technological speed. We have taken the slowest part of the carbon cycle and made it terrifyingly fast. We have connected the deep, ancient geological past directly to the immediate atmospheric present. This is the core of the imbalance. We are not just burning wood from this year's forest. We are burning the fossilized ghosts of a forest that has not existed for 1/3 of a billion years. The planet's normal breathing mechanisms, the oceans and the land, are struggling to keep up with this sudden, enormous injection of ancient carbon. They're absorbing about half of it, as Keeling's curve showed us. But the other half stays in the air, a gift from a long-dead world that our current world does not know how to handle. This leads us to the great paradox, the paradox of the observer who is also the agent. For all of human history until now, we have been characters within the story of the carbon cycle. We were the deer in the forest, eating plants, breathing air. We were part of the balance. Now, we are not just characters. We have become the authors. We are writing the next chapter with our actions, and we're doing so without fully understanding the language in which the book is written. We have stumbled upon the planet's source code, and we are rewriting it, line by line, with every flick of a light switch, every turn of an ignition key. This introduces a truly unsettling phenomenon, one that mirrors the strangest corners of physics. The measurement problem. In the quantum world, the act of observing a particle forces it to collapse from a cloud of possibilities into a single, definite state. The observer changes the reality they are observing. We are now doing this to the Earth. By observing the climate, by measuring the carbon, by understanding the cycle, we are becoming aware of our role in it. And that awareness presents us with a choice. The future of the carbon cycle is no longer a set of predetermined geological and biological processes. It has become a superposition of possibilities. There is a future where the planet tips into a hotter, more chaotic state, with feedback loops we cannot control. The melting of permafrost releasing vast stores of methane, another potent carbon gas. The warming oceans becoming less efficient at absorbing CO2. The dying forests turning from carbon sinks into carbon sources. And there is a future where we, the newly self-aware authors, choose to write a different story. A story where we learn to work with the planet's metabolism instead of against it. A story where we use our ingenuity to pull carbon back out of the air, to protect the great biological sinks, to transition to energy sources that do not resurrect the ghosts of the past. The act of measuring the Keeling curve was not just a scientific act. It was a moral one. It collapsed our ignorance. It ended our innocence. It forced us to see that our collective actions have planetary consequences. We are no longer just living on the Earth. We are creating it. And what does this mean for you? This is where the science of carbon atoms and atmospheric concentrations transcends itself and becomes a deeply personal, philosophical inquiry. This is the moment we must turn the lens from the planet back to the self. You're built from these cycles. The carbon atoms that form the elegant, complex molecules of your DNA, the proteins in your muscles, the fats that store your energy, are all travelers borrowed from this planetary flow. You are a temporary eddy in the carbon river. Think about what that means. The boundary you perceive between your body and the world is permeable. It is an illusion. With every breath, you are exchanging parts of yourself with the atmosphere. With every meal, you are incorporating the substance of other living things, plants that pulled their carbon from the air, animals that ate those plants. You are, in the most literal sense, made of sunlight and air. This is not poetry. It is physics and biology. So where is the you in all of this? If your physical substance is in constant flux, if you are completely replaced, atom for atom, every few years, what is it that persists? What is the thread of continuity that you call your consciousness, your identity? Perhaps you're not the atoms themselves. Perhaps you are the pattern, the specific, intricate, impossibly complex arrangement of those atoms. You are the music, not the notes. The notes are always changing, borrowed from the great symphony of the cosmos, but the song of you continues. This redefines what it means to be an individual. It suggests that individuality is not about separation, but about a unique form of connection. You're a localized, self-aware pattern within a much larger, interconnected whole. You're a way for the universe, for the carbon cycle, to know itself. Could it be that consciousness itself is an emergent property of this dance? That after billions of years of carbon cycling through non-living and living forms, through rock and gas and simple cells, it finally arranged itself into a pattern so complex, the human brain, that it became capable of reflecting upon its own journey. You, reading and understanding these words, are the culmination of a 4-billion-year experiment in carbon-based information processing. You are the cycle becoming self-aware. This realization is both terrifying and liberating. It's terrifying because it demolishes our sense of a solid, permanent, independent self. It reveals our profound dependence on a planetary system that we ourselves have destabilized. Our existence is contingent, fragile, and temporary, but is also liberating. It shatters the illusion of loneliness. It tells you that you are not just in the world. you are of the world. You are as connected to the Amazon rainforest and the Antarctic ice as you are to your own limbs. The health of the planetary metabolism is your health. Their breath is your breath. To harm the Earth's living systems is, in a very real sense, a form of self-harm. To heal them is a form of self-healing. This is not a moral judgment. It is a description of a system. What does it mean to be real in this context? Are the forests real? Is the ocean real? Are you real? If by real you mean fixed, permanent, and independent, then no, nothing is real. The mountain is a slow-motion wave of rock. The forest is a fountain of carbon. You are a pattern in a river. But if by real you mean a beautiful, dynamic, interconnected process, a dance of matter and energy that has persisted and complexified over eons, producing wonders like trees and whales and human consciousness, then everything is real, and you are not just a part of it. You are its leading edge, its conscious, questioning, creative frontier. So we return to the central question. The atom of carbon you exhaled just minutes ago. Where is it now? Perhaps it is rising on a thermal, joining the great river of the sky. It may drift for a few years, a silent passenger in the global winds, before being pulled down into the stomata of a leaf on a tree in a distant country. It might become part of a molecule of sugar, giving that tree the energy to grow a fraction of a millimeter taller. Perhaps that leaf will be eaten by an insect, that insect eaten by a bird. The carbon atom is now part of the bird. The bird flies for hundreds of miles on its migration. When it respires, it releases your carbon atom back into the air in a new hemisphere. Or perhaps your breath was carried out over the ocean. It dissolved into the cold surface waters of the North Atlantic. It became carbonic acid. It was taken up by a coccolithophore, a microscopic artist building its calcium carbonate shell. That tiny creature lived its short life and then sank, a speck of dust in the marine snow. Your carbon atom is now on a 1,000-year journey to the bottom of the sea. It will lie in the sediment, in the silent dark, part of the planet's slow geological memory, long after your name and your civilization are forgotten. It will become part of a future rock. And perhaps in 100 million years, that rock will be uplifted by tectonic forces to form a new mountain range. And as that mountain weathers, your carbon atom will be released once more as carbon dioxide back into the air of a world we cannot possibly imagine, ready to be breathed in by a form of life as yet undreamed of. This is the story of carbon. It is a story of connection, of transformation, of deep time, and the intricate dance of life and geology. It is the story of a balance, ancient and powerful, that we have now disturbed. Understanding this cycle is the great scientific and philosophical challenge of our time. It is not just about charts and graphs. It is about recognizing that we are part of a planetary metabolism, a single, vast, interconnected system. The carbon atom is the messenger. It is the thread that weaves everything together. It is the memory of the star, the substance of the forest, the chemistry of the ocean, and the architecture of your own conscious mind. It is not a thing. It is a journey. And you are not a spectator to this journey. You are a participant. You are a custodian. And you are a choice. Breathe in. You are borrowing the world. Breathe out. You're giving yourself back to it. The balancing act continues. And the next move is ours.